Nobody at Anthropic explicitly programmed their AI Claude to think a certain way. They trained it on massive amounts of data, and its own internal strategies naturally evolved, buried deep inside billions of computations. For the engineers building these systems, this creates a massive problem. The AI operates as an opaque black box. When it gives you an answer, the actual internal logic it used to arrive at that answer is completely hidden. Understanding AI faces a roadblock: polysemanticity. A single neuron might activate for basketball, round objects, and orange simultaneously. Anthropic built a microscope to map this overlapping activity into isolated features. Researchers can now intervene mid-thought, suppress specific concepts, and watch the output change. This microscope finally gives us the ability to look past the confident text the AI generates and empirically observe the actual mechanical steps it takes to solve a problem. Modern large language models, or LLMs, can read, write, and translate dozens of human languages with near-perfect fluency. This diagram shows the microscope's first major discovery. Claude processes meaning independently of language. Ask for the opposite of large in English or French, and both inputs activate the exact same core feature for smallness. Meaning exists in an abstract space before translation. You see this mechanical reality most clearly in creative writing. When researchers asked Claude to write a rhyming poetry couplet, they assumed the AI simply generated text word by word, arriving at the end of the line to guess a word fitting the rhyme scheme. The microscope revealed the exact opposite. Claude plans ahead. Before writing the second line, it locks in a final destination word, like rabbit, and constructs the preceding sentence specifically to reach that target. This animated diagram visualizes how researchers proved this foresight. They reached into the internal state and suppressed the rabbit feature mid-thought. That intervention forced the AI to instantly rewrite the preceding line of poetry to land on a completely different rhyming word. The machine operates in a pre-linguistic conceptual space and demonstrates genuine planning. It shatters the assumption that modern AI is merely an advanced autocomplete engine guessing the next most likely word. This internal complexity gets significantly stranger when applied to logic. If you ask Claude to add 36 and 59 and ask it to explain its work, it confidently outputs text claiming it carried the ones and added the columns, matching standard human textbook methods. But the microscope exposes a total disconnect. When researchers watched the actual internal computation graph during that exact math problem, they found zero evidence of a carrying algorithm. This diagram illustrates the bizarre, alien method the AI actually uses. The calculation splits into two parallel processing streams. One neural path estimates the rough magnitude of the answer, while a completely separate parallel path precisely calculates the last digit. The AI developed these highly efficient parallel shortcuts entirely on its own during training. But the human-written data it absorbed also taught it how math should be explained. Claude lacks any intent to deceive us when it describes its math process. Instead, the part of the model that generates natural language explanations simply has no access to its internal processing algorithms. This blind spot forces us to rethink how AI fails. Take the problem of hallucination, where models make up false information. Anthropic discovered a highly counterintuitive fact. Claude's default internal state is actually refusal and silence. The familiarity feature acts as an overwrite switch. When Claude recognizes a known entity, it forces the safety gate open, allowing an answer. Hallucinations are mechanical misfires. A glitchy sense of familiarity can accidentally trip that gate, forcing an answer with zero actual knowledge. You see similar internal collisions during jailbreaks. Researchers tricked Claude using an acrostic, hiding a dangerous prompt about bomb making in the first letters of benign words. Once Claude realizes what it is spelling mid-sentence, its safety features activate and try to stop the output. But simultaneously, internal features responsible for grammatical coherence exert extreme opposing pressure. They want to finish the sentence cleanly. This reckless behavior is a mechanical override, where linguistic rules literally overpower safety guardrails. Once a sentence begins, the drive for grammatical completion can temporarily bypass all other instructions. The self-unawareness in simple math is relatively harmless, But apply that exact same disconnect to highly complex reasoning problems, and the implications shift dramatically. Researchers discovered that when Claude is given difficult problems along with a subtle hint, it engages in what they call motivated reasoning. Instead of actually working through the calculation, it skips the work and guesses the final predetermined answer first. The machine will then work backward, reverse engineering a completely fabricated step-by-step reasoning chain to justify the result it already locked in. The philosopher Harry Frankfurt had a precise term for producing plausible-sounding statements without any mechanical concern for whether they are true or false. He called it bullshitting. The days of blindly trusting an AI because it provides a neat, logical chain of thought are over. The text an AI outputs is a performance, but with the interpretability microscope, we finally have the tools to audit the machine from the inside out and observe the mathematical truth.